Namaskar. Greetings from the Center for Ganga River Basin Management and Studies at the Indian Institute of Technology, Kanpur. In this talk, I want to make a case for utilizing appropriate combination of electromechanical and nature-based systems for treatment of domestic wastewater or sewage, than relying on either of the two, particularly with the objective of reuse and recycle of the municipal wastewater. As is abundantly clear now that municipal wastewater treatment and reuse is an acute need in developing and rapidly urbanizing countries like India, typically with increase in water demands and dwindling freshwater availability, as well as increasing wastewater generation in urban centers. These days, almost no surface water resources are spared from contamination with some or the other kind of wastewater, mostly the domestic wastewater. Typically, in most of the urban centers, the water is brought from a long distance and the sewage is also taken over a long distance and treated downstream. This scenario does not ensure cleaner water bodies in the urban localities. Drains, subdrains and urban water bodies remain dirty as they were earlier. Communities do not get benefited from this model. Hence, very less incentive or motivation for urban local bodies, ULBs, to spend their limited resources for treatment of sewage. And hence, ULBs pass on their responsibilities of managing sewage to state or central or federal government in violation of globally accepted polluter pays principle. Possibility of achieving appropriate treatment of urban sewage in India is very difficult, if not impossible. With this kind of approach, it is almost, I would say, next to impossible to manage pollution of water bodies, and as a result, we continue to increase pollution of our water resources. To illustrate and make a case for a paradigm shift in our approach, and which I believe is also likely to be the case in most of the developing countries, and I guess in times to come the situation may even develop in developed worlds. I am presenting some estimates before you to justify this. The table here shows the number of towns with population between 0.1 and 0.5 million, 0.5 and 1 million, and greater than 1 million. And if you go by the present practice, that is not talking about reuse and recycle, but just treating the wastewater up to secondary treatment, that is following the standards of say 30 BOD and 50 suspended solids in the treated sewage, not even talking about nitrogen and phosphorus or nutrient removal, then the resources that are required as per today's assessment is something to the tune of $3.5 billion US so far as capex is concerned, and about $1.3 billion US for annual operation and maintenance cost for just treating sewage in urban centers in India, and that is just about 18 to 20% of the total population of India. If we just talk about the Ganga basin, it is about 1.3 billion US dollar for capex and about 0.5 or half a billion US dollar for opex. And compare this with the allocated resources for the highly prestigious or so much talked about program of Ganga cleanup, Namami Gange, wherein for 5 years a sum of 3 billion US dollars were allocated over 5 years. And this requirement of 1.3 billion US dollar for capex and 0.5 billion US dollar for opex is only to cater to not more than 15% of the population, and that too only for sewage treatment, not talking about collection, conveyance cost, pumping cost, or not considering the remaining 85% of the population or other measures that are required for restoration and conservation of the river system. And with this kind of approach, in our opinion, it is almost impossible to sustain such efforts and achieve what we wanted to achieve. So, we need a paradigm shift in our water management practices, and that is what, based on our understanding of the situation, I am trying to present before you. With the resources made available, as I have argued, makes it difficult even to treat sewage up to secondary treatment, not to talk about the recycle level, where in advanced treatment, including nutrient removal, disinfection, etc. may be required. But the more important question is, if we do spend, if the local bodies do end up managing resources and spend their meager resources, what are they getting out of it? In the current practice, typically the sewage is taken downstream of the town, and then even if it is treated, it is released downstream. The situation in the town does not change at all. So absolutely there is no motivation for those towns to spend that much of resources, and that is where we are making a case that we need to have a shift in our approach. We have two extremes. One side, we argue for sewage treatment at least up to secondary treatment to attain uniform effluent discharge standards across the nation. And it is being said that even that is not enough. We have to go for reuse and recycle. That means we have to add some more treatment operations, advanced treatment operations like nutrient removal and tertiary treatment. On the other hand, this side, there is an argument that expenditure on electromechanical treatment systems which have high energy footprint is unnecessary, and nature-based systems which essentially require no operation and maintenance or least operation and maintenance costs should be adopted. Very commonly, such nature-based systems are referred to as, very loosely, bioremediation processes, for which as of now no discharge standards or norms even exist. With these two extreme views, we are not progressing as much as expected, and not sure if we are getting the value for the resources that are spent. And that is where our studies reveal that we must have appropriate distribution of resources for sewage treatment between STPs that are based on electromechanical systems and the nature-based treatment system, so that we do use STPs as well as nature-based systems. This approach focuses on improving the condition of urban drains and water bodies, and may even have more incentives for the towns or local bodies. They will get value for the resources that they spend, the resources they put in. This approach calls for decentralized wastewater treatment. So, instead of having one or few large sewage treatment plants, create large number of small sewage treatment plants, thereby reducing the conveyance cost of sewage, at the same time making sewage treatment plant where water is in demand within the town. Then there is a case for reuse and recycle, and there are chances of increasing revenue water as well. And this will in turn reduce pressure on water bodies, and or in other words, what we are arguing is we decentralize treatment, we put the treated water into the water bodies to treat sewage, partially utilize the STPs, and the remaining treatment should be achieved through nature-based systems, be it wetlands or local water bodies, and then take the water from these water bodies back into the municipal water cycle, as is shown here. So we are looking at number of small STPs distributed in the town or urban local body. Okay, and then utilizing the combination of electromechanical sewage treatment plants, the wetlands, be it artificially made or naturally available, okay, and then utilizing these drains or the water bodies within the town itself for the, and utilizing their assimilative capacity, and utilizing the natural capacity of nutrient removal, etc. If there is an excessive growth which is expected, then we can even harvest that and utilize that harvested growth for the energy purposes as well as biomass. So this is what is shown here, what we call it as 4-layer treatment. The first layer is in an appropriate electromechanical kind of sewage treatment plant. The second layer is a kind of wetlands, be it naturally available or even artificially made, and that can to some extent reduce the load of the nutrients. And then the water that comes out from this is passed on in the water body, and the water bodies are maintained. And then in the municipal water cycle, we take this water from here and again it passes through the conventional water treatment plant, and then it is reused. The two extremes that we are talking about is avoid this and use nature-based treatment. That has not worked well. The other extreme is just rely on sewage treatment plant and treat it to the level where it meets the reuse recycle quality and recycle it back into the system. I think we are missing somewhere something, and this is what we are proposing, and for that we need to make sure that we bring in some kind of policy changes. So this is referred to as the 4-layer treatment. The concept is basically about a 4-layer treatment system, wherein the first layer, as I said, is a STP. The second layer is a wetland kind of system, whether it is artificial or natural. Third level is the water body itself. And the fourth level is the water treatment. Instead of directly treating the sewage to a very high level and then using it for recycle and reuse purposes, which by and large, wherever has been imposed, as I said, or practice in India has not worked that well. So this is what we are proposing: distribute sewage treatment in the electromechanical treatment system and the nature-based treatment system, rather than adopting the extremities of treating either in electromechanical treatment system or in other alternative, leave everything to the nature. And I would like to demonstrate this through a live demonstration of a household level system. So it can be used from a household level to a community level or to a number of communities together, depending upon the situation, the availability of natural water bodies, the availability of land, etc. And the major advantage is we are avoiding long distance conveyance of sewage, and we are also making sure the local water bodies serve as a source of water. So to some extent we can even avoid long distance conveyance of water which is presently brought over a long distance. So let's go through a typical household level system which demonstrates this concept of 4-level treatment. At the household level, wherein sewage is collected, aerated through a system of fountains using a pump, and the system of fountains, it makes it aesthetically good scene, and the treated water is fed into a water body to sustain healthy indigenous aquatic life. In this case, water body is the small simulated river or a channel. And finally, water can be then withdrawn and appropriately treated to suit a particular beneficial use. In this particular case, the water withdrawn from the channel is used for gardening and horticulture purposes. This is a typical micro STP for altering the quality of domestic wastewater from a household. The wastewater is taken by gravity into a central well. The well is generally well mixed using the turbulence that is created by the recirculating water, and submersible pump is the only mechanical device that we have in this. But it does adopt a combination of treatment. Aeration is used, settling is used in the well, central well, the attached dose system is used at the bottom of the central well, and from the back fountain, part of the water is circulated through a root zone treatment system, or we can say wetland kind of system, and the remaining part is passed through the artificial river or channel. This is how the system looks like from a distance, and I will present details as we walk through this system. So we are now moving closer to the system. We saw it from a distance. This is the central fountain, that's the back fountain, below the central fountain we have the media which permits attached growth treatment system, and that is what you see, the central well. There is enough turbulence, it keeps it mixing. That is the level indicator, okay. And you can see the central fountain. There is enough aeration that takes place into this, and this is what you see is the root zone system, or you can call it a wetland system, and this is the channel. So this is, as I was telling, is the central well. Wastewater is collected to the central well, it is pumped, part of the flow is sent to the central fountain, and the part of the flow is diverted to the fountain, which is like a fall, okay, and the water or the sewage is aerated through a fountain which is like a waterfall at the back. The system also creates good aesthetics around it, as you can see, is a part of the household garden, and there is also a walkway. We can take a morning, evening walk, and essentially there are no smell or odor issues. This part of the wastewater that comes through the central well, okay, is first aerated through the central fountain and then treated using attached growth system equivalent to trickling filter, and then falls back into the well. The well, as I said, is well mixed. The water which is aerated through the back fountain is again distributed into the root zone system and the artificial river or water channel which maintains even good aquatic life, including turtles and fish. Volume of the water in the system is kept constant, and whatever daily input that we have is minus the evaporation losses is withdrawn and used for gardening purposes or horticulture purposes. Aquatic life, as I said, is maintained in this particular channel, which is an indication that the sewage is treated. DO levels everywhere in the system are well above 6 milligram per liter. BOD level is well below 8 to 10 milligram per liter. This kind of system can be scaled to localities, and the entire sewage treatment can be managed with optimal distribution of the capacities of artificial treatment system and the natural treatment system, thereby utilizing the resources optimally as well as maintaining drains and water bodies within the urban localities. This will help improving environment and well-being of urban centers and urban localities. Finally, I would like to argue and propose that instead of following the uniform effluent discharge standards, norms or standards should ensure that in the receiving water bodies, indigenous, healthy, aquatic life is sustained. And this is the shift that I am talking about. You can see the kind of aquatic life that sustains in this small artificial simulated channel. We even have fish which is sustained there, fish life that is sustained there in this channel. The channel is covered partially to avoid falling of other things into this, and this is how the whole system looks like. So we have seen the entire system. You can see the labels here of different components, and if you have any questions, any comments, any suggestions, you may send that to my mail vinod@iitk.ac.in or vinod.tare@cganga.org. Thank you very much for your patience.